Welcome to acceleration. On this video, we'll be looking at the rate at which an object, whether a bicycle or car, speeds up. Okay, so we're looking at the change from one point of a speed to another point of a speed. Let's look at the question. A bicyclist accelerates at a rate of 0.72 meters per second squared during a 4-second period or interval. What is the change in speed of the bicyclist and the bicycle? Okay, of course, that's together. Okay, so this is what we have. We have the acceleration, we have the time. I am looking for the change in speed. Okay, and we have an equation for this. The equation is acceleration equals change in speed. This little triangle means change. That's delta change. Change in speed divided by the time. Okay, let's see what I have. I have my acceleration. Yes, I do have my time. I'm looking for the change in speed. So this is what I'm missing. I'm missing the change in speed. So I will rearrange this equation and bring the time up. Now I'm going to have acceleration times time equals the change in the speed. Now you just plug in the values and they have that my acceleration is 0.72 meters per second squared. Okay, I have 0.72 meters per second squared times my time. My time is 4 seconds. Okay, place the video on pause and see if you could do this calculation. Okay, 2.88 meters per second is the answer. If you got 2.88 as the change in the speed in 4 seconds, okay, that is the right answer. Notice that the question is given to me in meters per second squared. Therefore, the answer must be also in meters per second. The square went away. I am looking for a speed, and a speed, of course, is a distance over a certain time. Next example. Question says, an automobile accelerates at a rate of 2.17 meters per second squared over a period of 8 seconds, okay, to reach the final speed in the expressway. If the final speed is then 31 meters per second, what is the initial speed when it began accelerating? Express your answer in kilometers per hour. A little more complicated. Let's work it out. Let's see what we have. We have acceleration, we have time, and we have final speed. The equation looks as follows. The equation says acceleration, as we did earlier, equals change in speed. And change in speed simply means final velocity minus initial velocity or speed divided by your time. And according to the question says what is the initial speed? I am looking for the initial speed or initial velocity. So I am simply looking for this right over here. I'm looking for that variable right there. So I need to rearrange the equation and make sure that I end up with initial velocity alone. When I do all my calculations, I'll do all my movement and so on. The initial velocity looks as follows. Initial velocity or initial speed equals, and this is where it gets very tricky, and you've got to be very careful on how to manipulate your variables. So the initial velocity is the final velocity, which I do have, minus the product of acceleration times time. When you do all your manipulations, this is what it looks like. Okay, simply what I did, I brought the time up and I brought the final velocity to my left, and I end up with this equation. Why negative or minus acceleration times time? Because the initial velocity cannot be negative. Therefore, the signs which were changed at the end. Now it's time to plug in the values. Final velocity is 31 meters per second minus the product of acceleration 2.17 meters per second squared times my time, which was 8 seconds. Okay, place the video on pause and work out this problem. Okay, here's what I got. The answer that I got is equals 13.64 meters over second. But wait, the question says express your answer in kilometers per hour. So I need to make another conversion. Okay, I know that 1 kilometer equals 1,000 meters, and I know that 1 hour equals 3,600 seconds. Okay, let's set it up. So I will now convert from meters per second to kilometers per hour. Let's begin with what's given to us. The answer is 49.1, and that will be kilometers per hour. How do I know that I have the right units? Because let's see, meters cancels with meters, seconds cancels with seconds. The only units that I have left are my hour and my kilometer. That is why my answer is in kilometers per hour. And we just converted from meters over seconds or meters per second to kilometers per hour. Simply, I divided by 1,000 and I multiply by 3,600. Those numbers will always be the same when you convert from meters per second to kilometers per hour. I hope this helps you out.